Okay, today we're looking at section 7.5. How do you use logarithm properties? Okay, so the logarithm properties are on a poster in my classroom, green poster on the wall. And they're also right here. The first one is the product property. So if I take the logarithm of a product, I can break that up using addition. Okay, so log base b of m times n is the same as the log base b of m plus the log base b of n. So for example, if I took the log base 10 of 50, it's equivalent to the log base 10 of 5 plus the log base 10 of 10, because 5 times 10 is 50. Or I could change that to log base 10 of 2 and the log base 10 of 25, because 2 times 25 is 50. Okay. The quotient property, so if I take the log base b of a quotient, division, I subtract. Okay. So for example, the log base 4 of 2/3 is the same as the log base 4 of 2 minus the log base 4 of 3. Okay, so in logarithm world, multiplication goes to addition and division goes to subtraction. Okay, and the final property is called the power property. If I have log base b of m to a power n, I can take the exponent and put it in front of the logarithm. Okay, so if I have log base 3 of 64, which is the same as the log base 3 of 2 to the 6th, I could rewrite it as 6 times the log base 3 of 2. So it's just ways to simplify and rewrite logarithms. Okay, so one example here. Let's say I know log base 6 of 5 is approximately equal to 0.898, and the log base 6 of 8 is approximately equal to 1.161. You can commonly find logarithm tables in the back of textbooks where you can find these values. Okay, so if I want to find the log base 6 of 5 over 8, I can use the quotient property. Okay, so the log base 6 of 5 over 8 is the same as the log base, log base 6 of 5 minus log base 6 of 8. So I know what the log base 6 of 5 is. It's that 0.898 minus 1.161. And if I subtract those, I get negative 0.263. Okay. Log base 6 of 40. If I know these, I can figure out how am I going to get 40 from 5 and 8. Well, 8 times 5 is 40, so I know that this is going to be the log base 6 of 5 plus log base 6 of 8, because 8 times 5 is 40. So I can add those 0.898 plus 1.161, and I'm going to get 2.059 on that one. This one I could do a couple ways. I could change this. Well, I could go 8 times 8 and just add this twice, or I can change it to log base 6 of 8 squared, and then I can write the 2 in front of there, so I get 2 log base 6 of 8, so that's 2 times 1.161. Which is 2.322. Log base 6 of 125. 125 is 5 cubed. So this is going to be 3 times log base 6 of 5, which is 3 times 0.898. So I get 2.694 as a result there. So this is just applying these properties. We can also apply it to simplifying expressions, expanding expressions and condensing expressions. So if I want to expand an expression, I want to make it larger. Okay, so I want to take it from one logarithm to multiple logarithms. Okay, so I can use these properties. I have multiplication combined with division. So I can apply the product property and the quotient property here. So this is going to be log base 6 of 5 plus log base 6 of x cubed, because it's multiplication, and then I'm going to subtract log base 6 of y, because that's division. Now the last thing I can do is take the exponent and put it on front here. I'll just do that without having to rewrite it, and that would be my expanded expression. Okay, this one a little simpler, multiplication, so I change it to addition. Log of 3 plus log of x to the 4, and I put the x on, or the 4 on front here. So that's expanding an expression. Condensing is the opposite. This is more useful because we're trying to take something that's a little bit more complicated and condense it into a single logarithm expression. So the 3 can be as an exponent, and it's addition, so we multiply. So this is just going to be log base 4 of, this is going to be x cubed when I put the 3 here, and then I'm going to multiply 2 times x cubed to get 2x cubed. Log base 4 of 2x cubed. Okay, and then finally this one, so this is going to be natural log of 3 cubed. So I'm going to take this one into steps here. So I got a natural log of 4 plus natural log of 3 cubed, which is 27, minus natural log of 12. So when I put this, break this, or put this together, it's multiplication and then division here. So this is going to be natural log of 4 times 27 divided by 12. Maybe I can do the 4 over 12 is the same as 1/3, and then 27 divided by 3 is 9. So this whole thing simplifies to natural log of 9. Okay, so that's expanding and condensing expressions. Last thing in this section, the change of base formula. We use the change of base formula in our calculator to evaluate logarithms. Okay, so log base c of a, where c can be any base, can be calculated by taking log base b of a over log base b of c. Base b can be any base as long as it's the same. So typically we would just use base 10, or we could use natural log, because these are the buttons we have on our calculator, log or natural log. So if I want to evaluate log base 3 of 8 on my calculator, I don't have a base 3, but I can take the log of 8 over the log of 3 on my calculator. If I do that, we'll go through it here. Log button, log of 8 divided by log of 3. Make sure you get the parentheses in there in the proper place. 1.89. That's what I'm going to get there. So that's the last thing. That is the last thing in this section. We will look at an application about sound intensity in class.